experimental probability. So it's frequently used in a lot of areas, and you can see in that opening sentence there, by having a pause of the video and reading it, that it gets used quite a lot in our society. So it's a concept that is very relevant, and it links to some of the things you've studied already about probability. So experimental probability has a second name which is used. Make sure you note that it's also known as relative frequency. So they mean the same thing. Frequency is how often something occurs, and it's relative to the whole amount, the total number of things, or the total number of trials. The word experiment in probability doesn't necessarily mean the same thing as it might mean in science or something else. So it just can be an activity. Alright, it can be interesting or boring or complicated or simple activity. So don't necessarily consider experiment to be the same thing as, say, in science or something else. So it can be just some sort of activity. So there's a formula there you must make note of, and here it is. You should note this, and this is the key formula for this video. An experimental probability is the number of times an outcome occurs over the total number of trials in the experiment. Trials are the number of times we repeat the experiment, or the number of times we repeat parts. Alright, so, and you can see at the beginning and the end of the formula you've got probability, experimental probability, and relative frequency. They mean the same thing. Now, an interesting thing that we see in the next point, in the long run. So once we have a large number of trials, what happens is that the experimental probability approaches the theoretical probability. So we have experimental probability starts to approach the theoretical probability once we do a lot of trials. What we mean by theoretical probability, for example, if we look at a simple example of dice, okay, on a die, a standard six-sided die, what's the probability of getting, say, a 4 on one throw of the die? Well, there's a single 4 on there, so in theory we have a probability of 1/6. However, if you did an experiment or an activity, let's say you threw 10 die 10 times, you would expect 1/6 of all them to be 4s, but it might not happen. But the more times you throw the die, the closer your fraction will be to 1/6, or its decimal equivalent. So that's what the long run means. It's very important. So we need to do a large number of trials, and all of these up the top here, all of these examples in society rely on a large number of trials. It's important to understand that. Let's look at an example below, and then it's time for you to have a go. So we've got an example. A box contains an unknown number of coloured balls, and a ball is drawn from the box and then replaced. So let's highlight the keywords. It's replaced. This procedure is repeated 100 times, and the colour of the ball is recorded each time. So we're recording the colour. 25 red balls were recorded. Alright, so it says find the experimental probability for a red ball. So we go use the same terminology or same symbols, probability of red, and remember the formula was the number of times it occurred. So number of red occurrences, the number of times red occurred. You can use a bit of shorthand, you can abbreviate things if you like, over total number of trials, which is just pretty much that formula you saw a moment ago that you copied down. Might have some slightly different wording. Well, we're after red balls. There are 25. What's the total number of trials? 100. 25 and 100, which is a quarter, or, if you like, 0.25. So, is that a large number of trials? Well, there's no definite answer, but 100 times is not bad. It's pretty good. So, you'd be saying the theoretical probability would have to be pretty close to 1/4 or 0.25. Of course, if you did it 1,000,000 times, okay, you'd probably get something even more reliable.